lesson, just so you know. Tomorrow's Veterans Day. If you know a veteran, please thank them for keeping us safe. Our freedoms are because of those people that are willing to enforce rules that we have and to help keep us safe. So yeah, I'm sure many of you know veterans, grandparents that might have been veterans, or maybe you have family parents that are in the military, or brothers or sisters. So yeah, if there is, you know, somebody that you know, please give them a huge thank you from me and from everyone else. Oh, that's interesting. Yeah, yeah. Marines are difficult. My my niece dated a Marine, and they dated for 5 years, and he was in Afghanistan, and he was sent there, and maybe 7 months later, he was one of the Jeeps, one of the very few that died, but his Jeep hit an IUD, and yeah, 23 years old and dead. So yeah. Okay. It is sad. It's very sad, but those people are called to help protect our freedoms, which is amazing, because it's something that I would have a difficult time doing, is joining the military. And there are some people that that's just in their blood, and that's great. So yeah, awesome. Okay, so off tomorrow, and everything is due on Friday. And now I'm going to give you guys some definitions. So if you have some room on the back of your periodic table of elements, you can write this down. If you don't have room back there, take out a separate sheet of paper. I'm going to give you some things that I would like you to write down. The very first thing that we're going to start with is I'm going to talk to you guys about matter. And I know we've talked about matter in the past. But what I want you to know is that matter, and this is something that you should be aware of, like, if there's anything that I want you to know, is that matter is never lost or used up. Matter can change, absolutely can change, but matter is never lost or used up. So like, let's say I have the process of photosynthesis, right? You guys have been learning about photosynthesis since you were in 2nd grade. Photosynthesis, in order for photosynthesis to take place, yes, matter matters, absolutely. In order for photosynthesis to take place, you need to have a green plant, right, which is going to absorb sunlight. It's going to use carbon dioxide, and it's going to use water, okay? Carbon dioxide is CO2. Water is H2O, which means that it's made of elements, right? C is carbon, H is hydrogen, and O is oxygen. So all of those elements are being used by the plant for photosynthesis. So they take those elements in, and it does not get lost. It's not released as carbon dioxide or water, but what happens is that there's a chemical change inside the plant when photosynthesis is taking place, and the matter gets changed itself. So it takes in carbon dioxide and it takes in water, but it gives off oxygen, and it also gives off something called C6H12O6, which is the simplest form of sugar that there is. So matter didn't go away. The carbon dioxide and water that the plant took in, that matter did not go away. It was just changed. So we never lose matter. That's the most important thing that you could, that I want you guys to know, is that matter is never lost. It can change, but it's never lost. Second thing is, a few definitions here, and I'm going to go over them with you guys. We have an element, and we've talked about the periodic table of elements, right? On the periodic, okay, yeah. Yeah, okay, let's go back to my definitions though, okay, Thomas, thank you. An element is a pure substance that cannot be broken down by chemical means. and it consists of atoms, right? So you know that we've talked about the periodic table of elements. You guys have it in front of you. There are 118 elements on there, all the way from hydrogen down to uranium and over to radon and then to neon and all elements. Those elements are made up of those atoms. So if I have gold, which is Au, the element gold is made up of all gold atoms. If I have potassium, which is K, the element potassium is made of all potassium atoms. If I have neon, the element neon is made of all neon atoms. So far, so good? Okay, so that's an element. Now let's say I want to take two or more of those elements and put them together. And we talked about it. We said H2O, CO2, right? So H2O is hydrogen and oxygen. CO2 is carbon and oxygen. If I take those elements and put them together, those elements, when they're put together chemically, when they're joined together, that's called a compound. So, I mean, there's NH4, there's CO, there's CO2, there's H2O, there's C6H12O6. I can go on and on and on and on. Those are all compounds. Okay, that's taking two or more elements, chemically joining them together. Yes, hang on, Aiden. No. This is it. There's not going to be any more writing after the ones that I put up there, and maybe a couple of letters, but that's all. Yeah. Okay. The last one that I put on there is a molecule. Now you can have all different types of molecules, and compounds are molecules, right? It's molecules or a neutral group of two or more atoms held together. So I want to take H2O, and I'm going to tell you something, show you some things about H2O and about writing when it comes to writing elements and when it comes to writing compounds. Look in the chat. Okay, stop. I don't want to lose what I'm writing in the chat. I want you guys to all see it. When you look at it, H2O, I've written it there, and it's got a really tiny 2, and the 2 is not even on the same line as the HO. It's like midway between it, right? We call the 2, you have to go on to like subscript something or other, and I just copied and pasted. Gibbles helped me do it today because you can't write subscripts in a chat. In the chat, you can do that, Samantha. I don't think that works in the chat. Yeah, it's interesting. Like on a Word document, you can. Yeah, yes, right. Or on a Google Doc, you can, but not in the group chat here. I know. So you have to copy and paste. Yeah, like I said. Okay, so I'm going to take it again because you guys were chatting. I'm going to put it in. Stop writing in the chat, please, everybody. Stop writing in the chat. Okay. There it is, H2O. The 2 is called a subscript, right? So you know how like when you in math, you can have a 2 above a number or an N2, and it's called an exponent when it's above the name or the number or the letter. When it's below it, it's called a subscript. And that 2 indicates a number, and in this case it's the number 2, and that number 2 indicates that there are 2 hydrogens. See where it says H2? H represents hydrogen, and that there are 2 hydrogens. Next to the O, there is no subscript. It's just H2O. So that means that there's only 1 oxygen. Okay, I can take another, and I can tell you for this one, and I told you guys that this is called glucose, C6H12O6. It has 3 different subscripts there. It tells you that there are 6 carbon atoms, because it's C6 and C represents carbon. It tells you that there are 12 hydrogen atoms because 12 is a subscript to the H. And it tells you that there are 6 oxygen atoms because 6 is a subscript to the O. So that one molecule of glucose, C6H12O6, that is one molecule of glucose. That one molecule of glucose contains a lot of different atoms there, yeah? Okay, so that's what a subscript is. Now, what I could do is, let's say I had multiple molecules of glucose. Let's say I had 3 molecules of glucose. The way that I would indicate that I have 3 molecules is if I would put the number previous to the compound. So it's telling you there that you have C6H12O6, C6H12O6, C6H12O6. The number 3 tells you how many of each molecule there are. So if I had 5 H2O, that would mean that I have H2O, 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 5 of them. So these are your compounds, right? Because you have 2 or more elements that are chemically joined together. If I had 1 C6H12O6, that is 1 molecule of glucose. The subscripts are the numbers that are below the line, indicating how many of each element there are. And the number that precedes it tells you how many of each compound there are. Okay, I'll give you a couple of minutes to write these things down. Yes, Tanvi, absolutely. I mean, I don't know, this is all semantics, I guess, but you don't literally mix the elements together. So they'll be charged. So the next module we're going to get into, we're going to talk about ionic and covalent bonds and what makes atoms attracted to one another. So, you know how I said, like, you have the periodic table of elements, and in column 18, you have your inert or noble gases. Those elements that are in there, yes, Tanvi, we'll talk about it more, but yes, and I'll tell you why. So the elements that are in column 18, column 18 are the inert gases, which means that their outermost shell of electrons is completely full. Those are the kids at the party that don't need to interact with anyone. They're happy and stable on their own, right? But when you take the elements all the way over in column 1, where you're talking about hydrogen and potassium, and column 2, sodium's in there, those are very reactive elements. Those are the elements, those are the kids that go to a party that always need to be interacting with other people, right? Because those elements do not have their outermost shell of electrons full. Now, in the case of hydrogen, and specifically hydrogen and oxygen, let's say I have oxygen is red. Let's say oxygen's my red ball here, right? If this is oxygen and I have H2O, what I'm showing you is that I have 1 oxygen atom and I'm going to attach to it 2 hydrogen atoms. So now I have H2O, right? For a water molecule, H2O, that is a covalent bond. A covalent bond is a bond in which the atoms share electrons, like they link arm in arm They're buddies, they're friends, they share together, they share nicely. But if you have something like sodium and chlorine, yes, they come together and they share. I'll draw it out for you and this, again, we're getting ahead of ourselves because this is module 7, but that's okay. They're going to share their electrons. But if you take something like NaCl, which is sodium and chlorine, right? NaCl is typical, NaCl is table salt, which means it has 1 sodium atom and 1 chlorine atom because there are no numbers as subscripts, right? So Na is sodium, Cl is chlorine. If you look where Na is located on the periodic table of elements, let me pull out my handy dandy periodic table of elements. Sodium is all the way in column 1, right? And in column 1, I have there in my outermost shell of electrons, I have 1 electron. It's not stable at all, Tanvi. That one, you want to have your outermost shell of electrons full. It is a metal. It's not metal like gold, but it has the same properties as metal. Okay, so it behaves like a metal. It doesn't have to look like a metal, but it has all the same properties of a metal. That's why it's classified as a metal. And if you look deeper into the periodic table of elements and you look, like you can research it on the web to see where your transition metals are. There's all different types of, there's alkali earth metals, there are all different types of metals, but just know that metals in general have a lot of the same properties. That's why it's classified as a metal. Na is in column 1, Cl is in column 17. Cl has 7 electrons in its outermost shell. And it only needs one more electron to fill that outermost shell for it to be stable. That's a lowercase l, not an I. It only has 1 electron that it needs to fill its outermost shell. So what it does is it takes an electron from sodium. Sodium doesn't share its electron, it takes its electron from sodium, and that's called an ionic bond. So there's a difference between ionic bonds and covalent bonds. And ionic bonds are either negatively or positively charged, depending on, you know, if they're going to gain an electron or if they're going to lose an electron. It gets a little bit more difficult. Chemistry is not easy. My chemistry is going to be fairly easy compared to the chemistry that you're going to get in high school. I wouldn't say that they're neutral, but they're a bit more stable. They're more stable than that of, because let's say I'm a sodium atom, and if I give away one of my electrons, then that sodium atom becomes positive because now it has more protons than it does electrons. If I am a chlorine atom and I'm taking that electron away, now I have 1 more electron than I do protons, so I'm more negative. Does that make sense, Tanvi? Yeah, it's a lot of info. Okay. No, Eden, if we were in school, we would be using chemicals, but because we're not in school, we have not supplied chemicals to you guys at your households, because then, oh my gosh, it would be like Breaking Bad in your house. I don't know. I mean, blowing up things and whatever. Yeah, that would be, it is complicated. Chemistry is complicated, but if you have a love of chemistry, you'll pick up to it really quick. And it's the same with math too. I can't, yeah, I do have some labs that are on the modules, but it's really difficult to be able to do this. Science is amazing. Science is always around you. Science is amazing. I want to address one question that Aiden had way earlier, and he was talking about atomic mass. When you're looking at the periodic table of elements, Like, let me pick an element for you, okay, Eden? I want you to find element number 7 on the periodic table of elements, and you can all do this. With element number 7, the atomic number is 7, and the atomic number always tells us how many protons are in the nucleus of an atom. So I don't know if I talked about this with you guys or not, but imagine that you have a bowl, an empty bowl. And in that empty bowl, we're going to fill it with Skittles, right? The empty bowl is going to be the nucleus of the atom. So imagine that the bowl is the nucleus of an atom. The nucleus of the atom contains protons and neutrons. It does not contain electrons, protons and neutrons. Let's say our protons are purple Skittles, okay? Protons, P, purple Skittles. Right now, our bowl is empty because we haven't made an atom yet. I'm going to take those purple Skittles, and for nitrogen, I'm going to put 7 purple Skittles into the bowl because my atomic number is 7. And if my atomic number is 7, that means that I have 7 protons. My purple Skittles represent my protons. So I put 7 purple Skittles in there. Now I've got my protons, but the nucleus also has neutrons in it. How many neutrons are in the nucleus of a nitrogen atom? If you look at the number below the element symbol and name, you'll see that it's 14.01. That number is the atomic mass, Aiden. 14.01 would be the atomic mass. The atomic mass makes up the mass, most of the mass of that element. Most of the mass is found in the nucleus. Now, I already know that I have 7 protons, 7 purple Skittles in that bowl. And if neutrons are red Skittles, and I have a total amount of 14 that should be in that bowl. I have 7 purple in there, and I should have a total amount of 14. How many of them should be the red Skittles? Seven, right? Because 7 plus 7 is 14. The atomic mass is how many purple Skittles and how many red Skittles there are. Does that make sense, Aiden? Yeah? Okay. I know candy's fun. And if we were at school, I would actually do this and you guys would get to eat them. Good, Thomas. I'm so excited. So let's take, let's just look at another one right now. Go to copper, number 29 on the periodic table of elements. Hang on, Aiden. 29 on the periodic table of elements. 29 means that there are 29 purple Skittles, 29 protons, purple Skittles in that bowl in the nucleus. There's 29 purple Skittles in there. But the total amount is 64 because we're rounding that number. If I have 29 purple Skittles, how many of them would be red? If the total amount is 64 and I have 29 purple ones, how many would be red Skittles? Yeah, try your math again, Aiden. Try your math again, Aiden. Try one more time. 64 minus 20. Yeah, there you go. So 35 of them would be red Skittles, and those red Skittles are your neutrons. So purple and red Skittles make up the bowl, and the bowl is the nucleus. It's okay. Does that help? Did that help you to understand it better though? Yeah, fantastic. Fantastic. Yeah, you can always use your calculator. That's fine. Yeah, I was thinking about that the other day, and yay, awesome, Tommy. There's an M&M factory in Vegas, and you can get any color M&Ms that you want. So next year when we're back at school, I'm gonna pre-order different colored M&Ms for this activity so we can make a bunch of different neutrons, protons, and atomic masses. So yeah, it's cool there, and using candy is very helpful to help you guys remember things. I don't know. I don't know when we're going back to school. So there are a bunch of different colors of M&Ms, and I figured I would use purple for protons because P purple, P protons. White is kind of a neutral color, so I would use white as the neutrons, and then the electrons would be red because electrons are negative. So Aiden asked about the electrons, and the electrons are always orbiting. Aiden, remember this, the electrons are always orbiting the nucleus of the atom. So they're on the outside of the bowl. You have your bowl with your purple and red Skittles in there, and then on the outside of the bowl are your electrons. If you have 7 protons, you have 7 electrons. If you have 23 protons, you have 23 electrons. If you have 102 protons, you have 102 electrons. Those always equal one another because protons are positive, electrons are negative, and you take the positives and the negatives and they negate one another. Yes, they have to be balanced. Otherwise, you're going to have a charge, which creates an ion, and we're not ready to talk about ions yet. But right now, you need to know that if I have 12 protons, I have 12 electrons. Like I said, it does get more difficult, and once you get into high school and then college, it's going to be even more difficult. I hope that I give you a really good understanding of how to use the periodic table. And you know, at least you would always be able to spit out that, you know, the atomic number is number of protons and number of electrons. The atomic mass is number of protons and neutrons in the nucleus. Yeah, good, Aiden. Okay. Okay. All right, enough about M&Ms. So now I've talked to you a little bit about bonding. We talked about the periodic table. You've got that down pat. You took out a couple of notes from me, and we talked about module 6. Does anybody have? Okay. You don't, Aiden, because if you know what the atomic mass is, right? This is what I want you to do, Aiden. You were given colored pencils. I don't know if you have them near you, but you should have red and purple. Do you have red and purple colored pencils? I'm gonna try to make this easier for you. Here. Okay. Here's a bowl, right? That bowl is going to be representative of the nucleus of a nitrogen atom, okay? There's a bowl, it's the nucleus of the nitrogen atom. We said that nitrogen has, oh, my daughter took my colored pencils. Ian, I need a purple, please. A purple and a red. Okay. In the nucleus of the nitrogen atom, if you look in the nucleus, or if you look at the nitrogen itself on the periodic table of elements, the atomic mass on the periodic, thank you, the atomic mass on the periodic table of elements, she was upstairs. Thank you, Riley. Okay, got the colors. The atomic mass for nitrogen on the periodic table of elements is 14.01. Do you agree? Okay, so it also tells you that there are, oh, thank you, buddy, but Sissy brought them down already. Thank you. It also tells you that the atomic number is 7. The atomic number always equals protons. So I can write this here. The atomic number equals protons, right? My protons are purple protons, right? Purple Skittles. If I have an atomic number of 7, I have 7 protons in there. Those are 7 purple protons. I know, he's so cute as Pikachu. 7 purple protons. but my atomic mass is 14. That means that all together in the nucleus, in my bowl, I have 14 protons and neutrons. Well, 14 minus 7 gives us 7. So that means I have 7 red neutrons in there. So imagine these are your Skittles. The total amount is protons plus neutrons. Protons are purple, neutrons are red. Altogether, I have 14. Does that make more sense, Aiden? Visually, that you can kind of see it? Okay, so take another element. Take chlorine. Look at chlorine, which is number 17 on the periodic table of elements. Again, draw a bowl. In your bowl, you have 17 protons. How do I know that there are 17 protons? Because the atomic mass always tells us that there are 17, or the atomic, not the atomic mass, I'm sorry, the atomic number always tells us how many protons there are. So you can take your purple pencil and draw 17 Skittles or purple protons in there. Okay, so I have 17 protons in the nucleus. Now, what is the mass of chlorine? If you look at chlorine, it gives you an atomic mass. And if you're looking where I'm looking, it says 35.45, which means that Tom V is right. It's 35 because we're going to round it to the nearest ones, right? So now if I know that I have 17 purple Skittles in my bowl, and I know that I have a total amount of 35 Skittles, I should have 35 in there all together. 17 plus what number? 17 plus what number gives us 35? (17 plus 18). So that means I need to draw in 18 neutrons in there, because the atomic mass is protons plus neutrons. If I know my protons are purple, what color are my neutrons? They're red, so I know that it's a total of them. Hopefully that helps you guys see it a little bit more visually to understand what's in the nucleus of the atom. And remember that most of the mass of an element is in the nucleus of the atom. That's all I've got for today. Does anybody have any questions?